Good afternoon, everyone. I'm Tomiko Brown-Nagin, Dean of the Harvard Radcliffe Institute, and I'm pleased to welcome you to this afternoon's virtual Radcliffe on the Road program titled Speaking with Whales, Listening to and Translating Their Communication. The Radcliffe on the Road series shares the interdisciplinary exploration and discovery that happens at the Institute with Radcliffe and Harvard alumni and friends around the country. I'm certainly looking forward to a time when this series can actually go on the road again so we can all be together, but I'm very pleased to have this opportunity to engage with all of you today. Let me extend a special welcome to members of the Radcliffe Dean's Advisory Council and the Schlesinger Library Council, the Radcliffe Institute Leadership Society, the Radcliffe Associates Program, and the Anne Radcliffe Society. Your generosity keeps Radcliffe programming, exhibitions, and collections free and open to the public, and we thank you. Before we begin, I'd like to share a bit about the work of the Harvard Radcliffe Institute for those who aren't already familiar with us. And to anyone joining a Radcliffe program for the first time, welcome. We're glad to have you. Radcliffe is one of the world's leading centers for interdisciplinary research and exploration. We bring students, scholars, artists, and practitioners together to pursue curiosity-driven research, expand human understanding, and grapple with questions that demand insight from across the disciplines. A commitment to inclusion and opportunity underpins all our work, and it connects us to our origin as Radcliffe College, an institution founded to make Harvard accessible to women who were then excluded from the university. One of the pillars of today's Radcliffe Institute is our residential fellowship program. Each year, we welcome 50 exceptional individuals working across disciplines and professions, and we provide them with protected time and space to pursue bold projects that advance the frontiers of knowledge and understanding. The Radcliffe Fellowship fosters a dynamic community where fresh approaches, illuminating art, exciting scientific discoveries, and solutions to pressing social problems can emerge. My own experience as a Radcliffe Fellow allowed me to see firsthand how invaluable the interdisciplinary exchange that happens every day at Radcliffe can be, and how unique the Radcliffe environment is within Harvard. This afternoon, we'll have a chance to explore one of the path-breaking research projects that emerged from collaborations built right here at Radcliffe. David Gruber, Michael Brunstein, and Shafi Goldwasser met as Radcliffe Fellows in 2017 and soon began exchanging ideas about how deep machine learning and natural language processing might be used to understand whale communications. These discussions evolved into a 2019 Radcliffe Exploratory Seminar, part of a Radcliffe program that provides funding to scholars, practitioners, and artists to launch interdisciplinary projects. The seminar led David, Michael, Shafi, and their collaborators to establish a nonprofit organization called Project SETI, which stands for Cetacean Translation Initiative. Now, I won't say too much more about the actual work other than that it is ambitious and truly interdisciplinary project. It promises new knowledge and encourages us to rethink human connections with other species on this planet. Now, let me briefly introduce our speakers. David Gruber, a 2017-18 Radcliffe Fellow, is Presidential Professor of Biology and Environmental Science at City University of New York and lead of Project SETI. Shafi Goldwasser, the 2017-18 William and Flora Hewlett Foundation Fellow at Radcliffe, is director of the Simmons Institute for the Theory of Computing and C. Lester Hogan Chair and Professor in Electrical Engineering and Computer Science at the University of California, Berkeley. She is also RSA Professor of Electrical Engineering and Computer Science at the Massachusetts Institute of Technology. And Michael Brunstein is Professor and Chair of Machine Learning and Pattern Recognition in the Department of Computing at Imperial College London. Michael was also a 2017-2018 Radcliffe Fellow, and he leads Project SETI's machine learning work. After their remarks, I'll ask David, Shafi, and Michael a few questions about their work before we turn to audience questions. You can use the Q&A feature on Zoom to submit your questions at any point during this program. We just ask that you please keep your questions brief so that we can address as many of them as possible. With that, I'm pleased to give the virtual floor to David Gruber.
Thank you very much, Dean Brown-Nagin. It is a pleasure to be here today, and Radcliffe played a truly transformational role in my career. Let me just share my screen. So I came to Radcliffe to explore jellyfish, which are a fascinating form of life composed almost entirely of water. And as part of this project, I was working closely with the Harvard Microrobotics Lab on bio-inspiration from jellyfish, and we designed ultra-gentle robots from their soft properties, some of the most gentle robots in the world. But the beauty of Radcliffe is that it brought me close to Shafi and Michael in this project that we're going to discuss today. So I'm a marine biologist and have studied many different marine creatures, but really there's two basic themes to my research. One is trying to use technology to be as gentle as possible, and that's with Rob Wood over here at Harvard to design robots that have the less stress on marine creatures. And then the other theme is really trying to see from the perspective of the marine creature. So in that vein, we've designed shark eye cameras and turtle eye cameras. But it wasn't that I got here to, it wasn't that I hadn't thought about researching whales until Radcliffe. And here I became interested in their sound and their form of communication called codas. So I was playing these sounds in my office when Shafi, whose office was across the hall, dropped in, and it sounded like this. Here's a little. So I'd been telling Shafi as well about the work of Shane Garrow and about his work showing that these codas and their relation to culture. And we began discussing the sounds, and she brought up the idea of using machine learning and invited me to this Radcliffe machine learning working group that she'd organized. And that also included Michael, who's an expert in deep learning, who you'll hear from next. And this led to the origin of Project SETI, which is the Cetacean Translation Initiative, which is this highly interdisciplinary interspecies communication effort that includes machine learning, cryptography, linguistics, robotics, and more. And really the goal here is to find ways to use technology to connect us to nature by really deeply listening. But just a few notes on sperm whales. Their Latin name, Physeter macrocephalus, emphasizes their really large brain, the largest brain known in the universe and 6 times heavier than a human brain. And it was not even known by the science community that sperm whales produce sounds until 1957. They're among the deepest divers. They dive more than a mile deep and hold their breath for over an hour. And the more we learn about them, they truly redefine the narrative presented to us in Moby Dick, where these are truly gentle creatures. They also live in matrilineal societies where the mothers and grandmothers really dictate the society interactions. So it's now my pleasure to pass the virtual floor to Michael to tell us more.
Thank you, David, and thank you very much for the invitation to be here. So I'm a computer scientist. So before I came to Radcliffe, I didn't know anything about whales, and I work in a domain that is broadly called artificial intelligence and machine learning. And when I came to Radcliffe, I was working on how to analyze social networks using special machine learning algorithms, trying to detect the spread of misinformation or fake news. And we later founded a startup company with my students that was acquired by Twitter 2 years ago. And what I really found is a unique feature of the Radcliffe Institute is the intellectual environment and very low walls, so to say, between different disciplines, and exposure to ideas and synergies that would probably be impossible anywhere else. And as David said, when he first talked about this idea together with Shafi about using machine learning to decipher sperm whales' conversations, probably my first thought was that it's the craziest idea in the world. I myself never seen a whale in my life, but somehow the question stuck in my head, and it's really the childhood dream of many of us, for sure myself, to be able to understand animals and possibly talk back to them. And now we are obviously not the first ones to attempt to understand the communication of animals, and researchers have looked into non-human species as different as, for example, spiders, birds, or recently even plants. And in general, in order to understand the communication system that might have language-like properties, and allow me to call it language in quotes, even though this term is highly disputed among linguists, we really need to answer three fundamental technical questions. First, what are the basic building blocks that can be reliably produced and recognized? And in human linguistics, this is studied by phonetics and phonology. Second, what are the compositional rules according to which these building blocks are knitted together? And in our languages, we call such rules morphology and syntax. And third, how these communicative units are used to transmit meaning, what we call semantics. Now, another question is how to choose among many different candidate species what we can call the right model organism for animal communication study. We need, for example, to make sure to start with that the animals engage in sufficiently interesting and complex behavior that at least potentially requires an advanced form of communication. They are, at least in principle, for example, physiologically capable of such communication, and that we can also observe all their communication modalities in their natural habitat. And it seems that sperm whales tick all these boxes. So they have very developed brains. As David mentioned, they're significantly larger than our own brains. They live complex social lives that happen underwater at great depths, where sound is the only reliable way of communication, and other senses such as sight are nearly useless. And their communication also has a rather simple encoding that appeals very much to computer scientists. And again, as you might have heard in the video that David played, it is formed of sequences of clicks. So we think that sperm whales are an excellent candidate for this model organism for non-human species language study. Now, obviously, it's always great to have a healthy dose of skepticism, and you may rightly wonder if many researchers have looked into animal communication in the past for many years. I would say probably to no avail. At least we don't understand what animals talk. Why do we arrogantly believe that it would be different this time? And I think that one of the key differences and technological enablers is that now, for the first time, we have technology that was not available in the past. And I'm talking about artificial intelligence methods known as deep learning. So let me show you what deep learning is nowadays capable of. And you probably have heard about it in many different contexts. So the text that you see here was entirely generated by a computer. And you can, if you read it, you see that it's of remarkable coherence that is probably nearly indistinguishable from text that is written by a human. What is even more remarkable that the machine learning model, a deep neural network called Generative Pre-trained Transformer, or GPT-3, that was used to produce this text, didn't know a priori anything at all about English, nor any other human language. So it was just fed with a massive collection of text, and it was trained to do the following task. So you take a phrase, you remove a word out of it, and you try to fill in the blank from the context. And this is apparently a very simple exercise. So my 7-year-old son is often asked to do it at school, but it actually requires this neural network to learn the structure of the language. And such learning is called unsupervised in the sense that there is no human assistance in the form of annotation, for example, telling the neural network that a word in a sentence is a noun or a verb or something like this. And deep learning systems like this one are now being widely used in the industry. They power some of our everyday experiences and interactions with our technology. from detecting spam in our email boxes to searching something on Google or communicating with Siri on the iPhone. And it's, without exaggeration, a revolution that has happened in less than a decade. And natural language processing is one of the fields where it has dramatically transformed. This technology has caused a dramatic transformation. And today's state of the art machine learning techniques in natural language processing are capable, for example, of accurately capturing different aspects of phonetics and phonology, syntax, sentence structure, and semantics. So in principle, they allow us to address the fundamental questions that we are looking at in animal communication. So it might sound quite straightforward at the first glance, right? Let's record whale sounds, run them through the latest and greatest neural network, and it will tell us what the whales are talking about. But of course, the reality is slightly more complicated. First, written human languages come in a kind of pre-segmented form into letters and words. So we know to start with what the basic building blocks are. And in the case of sperm whales, of course, we don't. We don't know whether these are individual clicks, whether these are sequences of clicks, what is called codas, or maybe each click individually carries additional, let's say, spectral information that we currently don't know. And this, to start with, makes the problem much more complex. Second, the amount of data that went into training GPT-3 was very large. It's about 500 billion words. So if I were to read them all to you, you would sit here until here 8,362. Yeah, I will not do it. So we don't have anything even close to this scale in marine biology. And one of the main challenges is to collect a sufficiently large and rich data set of sperm whale vocalizations. The third thing is that even the most advanced machine learning models, such as GPT-3, do not really understand language. So they have a wonderful ability to statistically associate words, but when it comes to semantics, there are many examples when they can fail miserably. And this means that while we can potentially find a whale grammar, in order to really understand what they are talking about, it's not enough to just record a lot of sound. We also need to associate them with the whale's behaviors to understand, for example, who is speaking each time, capture a discourse between multiple animals. And this is perhaps the most difficult part. I don't think that we, at this point, have a ready recipe for how to do it. So we are trying to collect as much as possible contextual and behavioral information. What is also common in animal studies, and a approach that has been tried in the past, is what is called playback experiments, where pre-recorded vocalizations are played to animals and one looks at how they react. So machine learning allows to do something much better, a kind of whale chatbot that interactively responds based on the context, potentially engaging in conversations with real whales in real time. And from their responses, we might be able to better understand what they are talking about. Now we are working in Dominica. It's an island in whose waters there is a large permanent population of sperm whales. We're building specialized hardware that would allow us to collect an unprecedentedly large and detailed data set of sperm whale communication and behavior. So David mentioned Rob Wood. He's designing special tags that would be attached with suction cups to the whales and track their behavior and record their voices. And what is important that we are building all these data sets for automated analysis by machine learning algorithms rather than by humans by hand, as it was done in the past. And we currently estimate that it would be able to collect billions of sperm whale clicks and associated metadata that will result in a data set that is similar in order of magnitude to those used to train human language models. And these data will be used to train different ML models, not only to provide answers to some of the big questions that I outlined before concerning sperm whale communication, but possibly we can also use these data to ask new questions that at this point we have not thought of. Maybe somebody else will come up with them. And we are really just in the beginning of this journey. And I really hope that our work will lead to some shift in the way we treat our environment, and maybe it will result in more respect for the living world. So it's now my pleasure to pass the virtual floor to Shafi Goldwasser.
Hi, everyone. It's a pleasure to be back here at Radcliffe, even if it's on screen, and I'd like to share my presentation with you. Great. So I'm Shafi, and I'm the director of the Simons Institute at Berkeley. And I spent the year at Radcliffe 4 years ago in 2017, 2018. And similarly to what my colleague said, it really was a highlight of my intellectual adult life. And prior to that, I was at MIT, which is down here, which is down the street from Radcliffe. I was there a professor for 35 years. And for many years, I heard from my other colleagues at MIT that they spent a year at Radcliffe and how wonderful it was and how sort of intellectually stimulating and some leaps that they've made. So I've always wanted to try it, but never had any time because really as a faculty member, you are kind of swamped in with responsibilities, supervising students, teaching, doing your own research. There's really very little time that we have to take time to do something different and to pursue questions that we wouldn't do normally. But when I was moving to Berkeley, I had 1 year and I decided this is the time before I leave Boston to go to Radcliffe. And luckily I was accepted. So I want to tell you that my project at Radcliffe, differently that David, not different, similarly that David said that he was going to study jellyfish, I'm a cryptographer, and I was going to study private machine learning. So cryptography is the field that governs secure communication, whether it's private, authentic, and so forth. And these days, with the advent of machine learning and the fact that really having tons of data is what propels much of the advances. And that's true for health, for finance, for economic growth, and so forth, vision, natural language understanding. It's also a shift of power from data that's held by individuals to data that's held by often large companies. And the question of privacy of this data is very important. And that's what I was going to be studying, how to do machine learning while keeping data private, how to verify machine learning models, how to make them robust. And to say that I actually completely accomplished what I set out to be would probably be false. But I did accomplish my project to some extent, but it was much more interesting what came along without intent. And I think that's probably true for some large fraction of people who come to Radcliffe, is they come to do X and they end up doing Y, and later down, maybe they'll do Z and so forth. So in particular, our story started, there was this I wanted to do private machine learning, so I had to learn really what machine learning was about. And this was a perfect opportunity. So I sent out an email to the Radcliffe Fellows and asked who wants to join. And we had lawyers, musicians, marine biologists, journalists, physicists, and 3 computer scientists, I think. Michael and I and Cynthia Dwork were the 3 computer scientists. And we had a sequence of lectures by other people who came and gave us presentations. And one of them was by this postdoc at Harvard at the time, Jonathan Bellingkopf, and he talked to us about NLP. And it was fascinating to talk about what the methods are for the natural language processing uses, that's NLP. And one of the most fascinating part about it was the automated language translation. The languages, of course, that he was discussing was going from English to French and French to German and English to German and vice versa. So languages which are quite close to each other, at least in the sense that they use the same alphabet. But he was talking about unsupervised translation. So in other words, you really are giving sort of the machine the freedom to translate without giving it any hints or grammatical advice. You're just giving it large collections of data. You might tell it that words appear in a context, but not much more than that. I thought that was fascinating. And that's why I went to David's office. And at that time, that was going on in my mind. So obviously, people, French, Deutsch, English, Wales, it's all the same. Clearly not. This is tongue in cheek. But this is where kind of, I think the inspiration came from. Now, as Michael described to you in great detail, and well, in some detail at least, because we don't have that much time, the hope is that we will be able to find out what the units are, or if we're using human terminology, what the words are, what the composition rules are, so what the sentences are. But we have to remember that, so this is the whale, sorry, coming in. Well, we have to remember that machine learning, and in fact, the most advanced tools of machine learning, which are these deep neural nets, is very successful, but far from being extremely well understood. And I think that in our context, especially, we want to get interpretable model because we want to really fundamentally understand something about non-human communication. And we will need to come up with some formal models. And then we will use possibly the machine learning tools to maybe either tell us that our models are consistent with what we see or that our models are incorrect. So in some sense, they will be able to constrain the space of our hypotheses and our conjectures. So since I am a theorist and a sort of mathematician, that's my area of computer science, I guess I'm ultimately interested in sort of abstracting some of the questions that we're going to be studying in this project regarding communication. And just to remind people who come from science and maybe people who come from any kind of discovery, often, what we ask, the questions we ask are, I wouldn't say they're as important as what we find, but it's a very important part of every scientific endeavor. So just a few questions. One question is, people continuously say, and I think Michael referred to it, that language, that we shouldn't use the word language. We should use the word communication. It seems to me that we have something in between here, where these whales, these creatures are communicating with some sort of a goal. So they're communicating for a reason. So perhaps there's some intermediate notion, which is not language, not mere communication, but communication with a goal, which is actually a term inspired by some research by some colleagues of mine who were also Radcliffe Fellows in 2003, I think, Goldreich and Sudan. And the basic idea is that the communication that we have has a goal. And if the goal is achieved, it must be verifiable. So we can verify whether a goal is achieved or not. And if that's the case, then we might have a chance to test whether we are understanding communication or not. Because we can we can verify whether the goal has been achieved or not. So I think for whales, maybe one of the questions we should ask, what's the goal? And we all have some intuitive ideas, we always go to the lowest common denominator, right? You say, oh, they just want to eat and they want to find out where they are. I don't know, but the goals are clearly important. Another thing is that refers to the language translation. As I said, English, German, French, they're quite similar to each other. We're not expecting that the whale languages will be similar to us and we'll just feed them in and somehow English sentences will come up. But possibly we could translate between different whale families, different in area, maybe different types of whales. And that's something that seems to me completely possible. Of course, the most interesting question is, even if we are able to translate and figure out what the words are and the composition rules, what are they saying? How do we attach meaning? And one of the, lectures that we got from Jonathan talked about this completely unsupervised language where you have no idea, but you have an anchor. There's some pairs of words across languages which we do know what they mean. Or maybe you can align text and align them according to the anchors, which might be even just digits or counting. So it's an interesting question. What would you define as anchors for, whale translation? Maybe the goals are the anchors. It's an interesting question. Other things that fascinate me is error correction. So in human language, we speak in such a way that we can understand each other, even if we don't understand each other right away. So there's some redundancy. Similarly, we develop very complicated error correction methods for phones, for computers, because there's noise on the line. That must be the case also in whale communication, especially since they communicate over long distances and in water. So it would be interesting to investigate what is the role of error correction, what kind of error correction is being used. Language compression actually is something that's been used to detect authors. So to be able to distinguish different authors, just given text written by different authors, compression usually works because different authors compress differently. You can also distinguish whether we're talking French or English just by how compressed the language is. I wonder if that extends to whale communication. Of course, we need to know what the alphabet is in order to know how to compress. And then there's a question about memory. How we think we are so sophisticated. Whales have very large brains, but how much of that is necessary to process communication? How much, what is the complexity of the communication? And that might give us some hints if we study this for whales, and the same methods can be used for other non-human. Is there some hierarchy? A hierarchy of complexity, maybe that's connected to evolution. I think these are fascinating questions. In fact, I think as Michael alluded to, we had a seminar a workshop in Berkeley in Simons Institute where we had a lot of people who are studying non-human communication. People talked about gorillas and bats and birds, and there was actually one speaker, Lila Khadani from Tel Aviv University, talked about plants, where she went out to study that, trying to convince that plants don't hear, and then she found out there is sound communication between plants. I think now she's working on actually discoveries that indicate that plants might even talk and not just listen. And interestingly, the methods that she uses are not that different. Again, it's using machine learning. It's using the type of machine learning that we are going to explore in our project and are being explored already. And the last thing I want to say is that there's a lot of unintended consequences of this project, and I mean good unintended consequences. So there are robots that are being developed. There's new sonar activity. There are these buoys that record sounds, tags. I think that it's like the space exploration. Many, many things were discovered that have nothing to do with exploring space, and maybe in the long run became even more important than space exploration. I expect the same will happen here. And I just have one more slide because I know I'm out of time. And I mentioned that there were artists in our pod, and during my Radcliffe year, even though I was studying privacy and machine learning, and now we're talking about whales, I did one other project with a friend who's an artist, Jill Hoy. She's a local Somerville artist, and it was called Women in Transition because I was transitioning to Berkeley, and she did portraits of a bunch of women who were fellows. This is Ifoma, she's a playwright, and this is Martha, who's a dean of the law school, and these are two of her portraits. And here's Jill sitting and taking a portrait of Jane, who is actually now the associate dean of science in Dartmouth. So I'd like to return the microphone to Dean Brown-Nagin and to have her lead our discussion. Thank you.
Wonderful. Thank you so much to Shafi, Michael, and David. That was a fascinating discussion, and your collaboration truly represents what we hope for, the height of what we hope for during the Radcliffe Fellowship experience. And the truly remarkable thing, and I want to underscore this, is that you all were here as fellows, but none of you were originally here to study whales. Which is just fantastic. I was going to ask you all to comment on your individual projects, but it sounds as if in your remarks you did that. Perhaps I can ask you a question about, to flesh out where we started, how exactly from these conversations Project SETI got off the ground.
I think it's really a testament to Michael and David's tenacity. So it's true that I came by David's office and talked to him about translating whales. And Michael, even though a skeptic, was willing to entertain a conversation with us. But then they really pushed forward, and I think that you guys should comment on this. How did we get to where we are now?
Why don't you take it next, Michael?
Yeah, so, well, as Shafi said, and as I also mentioned, so to me it sounded like a completely crazy idea. So I thought, well, of course, at that time, there were some works in natural language processing showing that you can do unsupervised translation between different languages like English and French, but, well, they are human languages, so they kind of describe the same reality. And even though the words and the grammatical structure might be different, you still can expect some similarity. In case of whales, they describe completely different worlds. There might not have even analogies to some of the concepts that we have or they have. So I was skeptical. Well, of course, another question is data. So David contacted Shane Giro, who is a leading sperm whale researcher that has spent about 15 years in Dominica recording their sounds. And I would say, great enthusiasm, but the collection of the data that he was able to collect over these years is, of course, nothing close to what typical machine learning algorithms require. So we looked together into using some of the machine learning techniques that, such as those that I described, maybe that existed 4 or 5 years ago, to try to do some of the tasks that they did manually with other techniques using machine learning. And it worked successfully, so it was actually pretty successful. Of course, a far cry from what we are trying to achieve, to understand language communication, but we were, for example, we're able to identify dialects in different clans, or even identify individual whales from the way that they speak. And that was encouraging. And then, well, I think David really took it forward to completely different point with the seminar that he organized at Radcliffe in 2019, and then we got the TED Audacious Prize. And David, I guess you can comment on this more.
Yeah, I guess there's two other areas where I think Radcliffe played a key role. Is one when one of the first things that Shafi and Michael said is what is the existing database of whale sounds? And so I'm also an explorer with National Geographic, and through my connections with National Geographic, got access to Shane Garrow, who gave us this beautiful data set, and a Radcliffe research assistant, Peter Bermont, helped under the guidance of Michael make some proof of concept, which then led to the Radcliffe seminar, which was really a beautiful 2-day meeting where we came together and kind of realized that the time is this moment in time. Actually, the window opened up where we think we could make significant inroads, and it was literally one day after that seminar that we started our application process for funding. And now here we are on we have a nonprofit, and we're on a multi-year journey, and working closely in Dominica, and building out other programs, leadership programs here as well. And yeah, we're really just enjoying the collaboration and the interdisciplinary aspects of this.
Good. Thank you so much for saying a little bit more about that. We're so glad that you began this exploration, and that you are at this moment now. And there are many, many audience questions. So I'm going to transition to some of them now. And the first is from a viewer who volunteered at a lab where dolphins were learning language during the 1980s. And this individual wants to know, knowing how social whales are, I wonder if you are most excited to learn in understanding what they say to one another. If you could speak to them, what would your first sentence be?
I'll just start out that, my personal is that I'm most interested in the fact that we're listening, and that we care to listen, and that such a unique group of individuals have come together to have the desire to want to know what's going on inside a whale's mind. So I'm just starting out there, and I don't come to it with any specific thing I'd want to say, but yeah, really coming just open with a sense of wanting to know more.
Yeah, I agree. I mean, somehow the idea that if we discover that they are speaking, let's say about a past event, I think it would be huge. I don't really care to talk to them, but just to understand that this is a much more sophisticated form of intelligence than we give it credit.
So I would also say that probably we tend somehow to dismiss animal communication by saying that, if they have language, why we don't see them doing some complex things? I think they might be doing, we just don't know. So it's a little bit arrogant to say something like this, because just maybe a couple of decades ago, we didn't even know that they produce sound. So we thought that they were silent. So as Shafi said, I think discovering that there is language, even without understanding it, there is something that's similar to language. So there is grammatical structure, that they are discussing something interesting, that this mediates their social lives. This would be a huge discovery. Now, whether we would be able to fully understand what they're talking about, I might probably be more reserved about it. As I said, it might be a completely different reality that will just not correspond to our mindset. But it's probably not necessary. So therefore, maybe the talking back to them is a kind of near science fiction, maybe at this point. But why not? So I don't know. So I somehow want to think of this moment when Neil Armstrong made the first step on the moon. I don't know whether he prepared now the canonical phrase, or maybe it came up to his mind at that moment. So we'll probably, hopefully, we'll get to this.
Great. So no first sentences right now. Now, there is another audience member who has read about a Swedish team using AI to attempt translation of dolphin clicks and whistles, similar to sperm whale codas. And they want to know if you're aware of progress in this area. If so, that's encouraging. And if not, why do this with whales before the dolphin results can be verified? Who would like to take that?
I would just, yeah, we are aware of, there's a lot of other groups now. This is a really active space. There's a group called the Interspecies Internet that's also got roots at MIT that's working at this. And one of the aspects of what we're doing is, since we're a nonprofit, we're basically putting everything up as open source, and I'm going to start a citizen science community that could help, come on the ride with us. So in terms of that, yeah, we're out in the open, and but I think we could talk more about why we're choosing whales, and that was a little bit in Michael's presentation. So maybe you want to answer that more directly.
Yeah, so there are several considerations. So obviously there are other potentially intelligent animals that also have, at least apparently sophisticated communication system. There are several reasons why we wanted to look at whales. Well, for whales, there is substantial experience. So in this case, this is the team of Shane that has been working in Dominica. So that was already a good starting point. It is relatively simple encoding, so clicks as opposed to some more complex signals, such as maybe the humpback whale song, the evidence of their social life. And we know maybe from other species that it is this kind of behavior that is mediated by language, or what could be called language, right? So more sophisticated communication system, also evidence of sufficiently developed brain, so at least potentially the right cognitive capabilities to have something that might look like language. So these are some of the considerations why this would be a potential species. I should say that we are really developing tools that might go well beyond whales. And as Shafi said, so we're trying to go to the very fundamental questions of imagine that you can observe a communication between any agent, right? So it can be an alien creature that, well, for many years we hoped to receive a transmission from somewhere in deep space, and we might still hear it. How would we approach this problem? How would we try to understand whether this is a language-like message, right, or is it just noise? So the tools that we are developing for whales, it's just the stepping board for potential other applications, including aliens. Who knows?
Shafi, would you like to add something?
No, I think about the Swedish project. I think in general, the idea here is collaboration, right? So it's a natural question. Why don't you wait till someone else? But it's a natural. I'm willing to bet that this is a question from a scientist. I think what's wonderful about this project to me, it's not related directly to my answer, but is that AI has been used quite a bit for profit, right? Like for the ad model. And, the more you know about me, the better you're able to sell for me. In some sense, the beauty in this project is that it really is pure scientific curiosity. And we're going to use these methods to discover something very, very basic. And if we manage to do that, whether it's the dolphins or the whales or the plants, it was, in some sense, I say it's all been worth it. It's just like, it's the beauty of this technology. Wow, we fundamentally moved the needle. I don't think it matters who gets to be first.
Wonderful. Thank you for that, Shafi. There are a number of viewers who have questions about ethics. One is, how do you know whether it's safe to the whales to play sounds back to them? Could this be disruptive to the whales? Could the use of sonar cause hearing damage?
Do you want me to take that one first, or?
Yeah.
I would just start out with, we're really calling this more of a listening project. Most of our efforts are really passive acoustics. The ideas of playback that were brought up wouldn't occur until the very end. And one of the real essence of that is to validate if our understanding is right, but also just to put it into framing. The anthropogenic sounds that we're making in the ocean today are just enormous. There's a whole bunch of great resources and documentaries, Sonic Seas, that show how the sounds of the shipping and the industry and the military are really having adverse effects on marine mammal populations. So in this aspect, we do hope to better understand, even by recording the passive sounds that are happening there, how anthropogenic sounds are further affecting them. And on the robotic side, we're approaching this with the most gentle, delicate robots, and so we're putting really great care into that aspects of it. So I think it's more about the framing for us and keeping it. We're not working with any captive animals, again, really mainly about listening and being as invisible as we possibly can.
Yeah, and maybe I can add to this that probably in many regards, this project brings us to an uncharted territory. So as you mentioned, there is a lot of discussion about ethics of AI and privacy, but it is always centered around humans and not animals. And possibly, well, I'm not an expert in ethics, but I could easily believe that many of the premises that are made in human ethics are not applicable to these cases. So we probably even don't know at this point what are the right assumptions. And we are trying, as David said, to be as delicate as possible with the whales, and at least in the context of how horribly we humans treat these and other animals, I think overall the benefits, or I hope the benefits, will outweigh the potential detrimental effects.
Yeah, I just want to say that I think that we are fully aware of the fact that there's benefit and there's risk, and there are sometimes unintended consequences which are negative. And I think the fact that we're mindful of it is very important, and we're careful. One also has to remember also the whaling is still something that's done. So, and hopefully if we understand better, we are also progressing toward greater respect of these creatures. So it is a question of on balance. And without trying to make progress, you don't make harm, but you don't get good either.
Right. Okay, so there's a somewhat related question. Could you detect an impact of water or noise pollution from boats or submarines? Maybe hear the whales complaining? Is the question.
So this is definitely possible, and the collection mechanism that we are now developing will certainly allow us to do it. So we'll be able to record the presence of human activity, and in particular anthropogenic noise, and we'll be able to see how the behavior of whales is affected. So this is definitely one of the issues that, for example, is very important for the government of Dominica. So they're very much interested in seeing, for example, how the shipping routes affects the population of whales in their waters.
Thank you. There's a question about how you deal with the possibility that sperm whale sounds might serve multiple purposes at once, such as communicating with other whales or imaging their environment with sound. Who would like to speak to that?
I can maybe short comment, and David certainly knows more about whales. Can expand. So we know for sure that they use their clicks for different purposes. One purpose is echolocation. So, and we actually know we can classify the clicks that are used for echolocation versus clicks that are used for communication. So for sure, there are at least these two purposes. One is, well, we can call it imaging of the environment in an acoustic way. And another purpose is, of course, communication, which we still don't understand. We know very little about its purpose or its meaning. But yeah, it's easy to assume that there might be some additional purposes, maybe just expression of art or emotion, or I don't know.
Which brings us to another viewer's question, and that is about whether you've been able to detect correlations between sound and behavior.
Well, I can also try to give it a shot. Yeah, so this is really one of the a crux of trying to understand the semantics of the communication, what is called grounding. So we can, well, as we discussed, so we can understand and we can discover the structure of the language, right? So we can understand that there are some basic building blocks that are somehow composed together. We can discover these grammatical rules. But as with human languages, right, I can listen to a language that I don't understand. I would know that this is a language. I would probably be able even to describe its structure, but I would not understand the word, right? So this is the kind of situation with whales as well. So by just looking at the acoustics, that's hopefully the point where we'll be able to get. So in order to understand, to assign some meaning, we also need to see certain associations with behavioral information. So that's why we are trying to capture this behavioral information. So whether it's simple motion patterns by tracking the whales, from the tags we can get more nuanced and more detailed information, such as the diving patterns, the depth where they dive, maybe well, some analogy of gait in humans. And we can see, for example, whether they do some kind of discussion or coordination before that. So, well, maybe this is my professional information, but I like to think of it as a kind of open social network, a kind of Twitter of whales, where we can see who speaks to each other, right? So what is called discourse. So we know, for example, even understanding the structure of their communication, whether they take turns like humans, right? So we don't speak over each other usually. First one person speaks, then another person speaks. This is not necessarily taken for granted in the animal kingdom. We don't necessarily see the same patterns in the data that we're looking at. There are some coursing patterns that one whale starts and another one continues at the same time. So it might be that their brain capabilities allows to send sound and receive sound at the same time, and they're not confused. So yeah, it's still big question marks.
Now, if we had questions before from a scientist, I'm pretty sure this one is from a humanist. Is it possible that whale sounds do not have a specific goal? What if there's something closer to human art, a recording of being, or a vessel of whale memory and experience, like a poem?
Well, maybe they are reciting poems to each other, but it seems like even if it is art, there is a listening. So I think it's not art in the void, but there is some evidence already that there's a discourse that's going on back and forth, that there is some form of conversation when there's a speaker and the receiver. Of course, also for art, we need an audience. I'm not sure there is no goal in art also, so I'm not sure I would say that art is without goal.
Right.
I would just jump in and say that there's a lot more questions than there are answers now, and I think that's one of the the beauties of this is that, even paying homage to how difficult it is to do this research, and the narratives that we have now that we're describing are the existing human knowledge on whales, which go back, many many millions of years. And, we've only learned about them in recent decades, the information that we have now. And that's due to scientists working with a few microphones in the water with equipment. So I think by having the kind of human investment in both brain and capital in this project, I think there's so much possibility of what we find. And it's really about, can we use technology to better appreciate nature and better understand them? And even as Michael said, if this might be the kind of basic technology that would be used for understanding extraterrestrial life, but do we have the capacity as a human to go in that direction? Are we talking to ourselves with enough respect that we're ready to now communicate with extraterrestrial life? So it brings up a lot of interesting things that we hope this project creates the dialogue that could house all these beautiful questions.
Wonderful. And we have time for one last question, and this is it. There's several people who are interested in learning more about progress to date, data collected, preliminary results, and what the way forward looks like. And these people also want to know if what you found so far suggests that you're on track for a big discovery.
We have a roadmap paper, which is we could share. It's on archive that we wrote together as a team that describes our results. Again, everything is going to be open source. We're setting up a GitHub account. Our website is www.projectct.org, and we'll be communicating as we move forward. We have amazing communication partners like TED and National Geographic that'll help share this message as well. And hopefully stay tuned.
So maybe I can add to this. So, we are looking, of course, before we have completed the design and the deployment of the specialized hardware that we hope that will start collecting the data next year. So we have archival data from Shane, which of course is smaller scale and not as detailed as we would like it to be, but still it has a lot of interesting insights. So we're actively working on it, and hopefully we'll publish some first results. So again, we don't know what the whales are talking about. What we see, we'll see a lot of interesting things that have never been observed before, and it's, in a sense, it's of course a lot of work has been done by biologists, but it's very hard work. So it's not surprising that little is known about these creatures, and I'm pretty sure that there will be a lot of exciting discoveries. The first ever observation of, for example, language acquisition in marine animals. So this is nothing that has been observed before. So we hope to see this as well.
Terrific. I'm afraid we are out of time, so we'll have to stop there. Thank you to David, Shafi, and Michael. And of course, thank you to everyone who joined us this afternoon. I encourage you to visit our website to learn more about other virtual programs taking place at Radcliffe this fall. Have a nice evening.